Question 1. Through careful analysis of a passenger ferry's HVAC cooling system, technician Lisa observes that seawater strainer baskets are clogging every 3-5 days, leading to reduced heat rejection at the condenser. She confirms that the seawater around the intake has high organic content due to seasonal algal blooms. Given the constraints of the marine environment, which of the following is the most appropriate solution to reduce strainer clogging and maintain condenser performance? A. Increase the seawater pump flow rate to flush out the strainer contents more frequently. B. Replace the strainer with standard HVAC inline filter. C. Install self-cleaning seawater strainer with automated backflush capability. D. Eliminate the strainer altogether to allow uninterrupted flow to the condenser. Answer. Correct answer. C. Explanation. In marine systems, strainers prevent debris from damaging downstream components. In high-fouling environments like those affected by algal blooms, self-cleaning strainers with automatic backflush cycles ensure reliable flow and reduce maintenance. A Baikonur requires seawater intake protection, and eliminating the strainer D violates these codes. A larger pump may increase flow but doesn't resolve fouling. Standard HVAC filters B are not designed for marine water systems and corrode quickly. Reference ABIC P1 and USC subchapter T. Question 2. Based on the information about international refrigerant regulations, which of the following is an appropriate action for a marine HVAC technician who needs to service a vessel operating in both U.S. and European waters and containing an R404 refrigerant system? A. Immediately vent the R404 to the atmosphere during servicing in international waters. B. Replace R404 with R22 to comply with new European regulations. C. Use HEPA-certified recovery equipment and document refrigerant quantities during servicing. D. Install a bypass valve to allow manual discharge of refrigerant overboard when pressures rise. Answer. Correct answer. C. Explanation. R404 has a HEPA is subject to strict handling under the HEPA Section 608 rules and the EEF Gas Regulation 517/2014. Recovery and documentation are mandatory. Venting refrigerants AD is illegal under both HEPA and EU regulations. R22B is being phased out globally under the Montreal Protocol. Technicians must follow proper recovery, recycling, or reclamation methods. Question 3. To illustrate this point, a marine HVAC engineer is sizing a chilled water system for a 110-feet yacht with mixed-use zones, galley cabins, engine room. The system must ensure thermal comfort, moisture control, and energy efficiency. What is the most critical design step to ensure accurate capacity matching? A. Selecting the most powerful chiller available within the budget. B. Calculating sensible and latent heat loads for each zone independently. C. Using a single average load value for all compartments. D. Prioritizing aesthetic considerations of air handlers over performance ratings. Answer. Correct answer. B. Explanation. Load calculations are the foundation of HVAC sizing. Marine environments include variable humidity and internal gains, e.g. galley heat engine room. ASHRAE standards and ABIC guidelines require independent zone load analysis to account for latent and sensible heat. Oversizing A leads to short cycling and inefficiency. Averaging C ignores zone diversity. Aesthetics D do not outweigh technical performance. Question 4. During the process of inspecting a malfunctioning control panel on a marine chiller system, technician Emir notices that the relay controlling the compressor contactor is energized but no current reaches the contactor coil. What is the most likely root cause? A. The relay's coil is drawing too much current. B. The compressor is mechanically locked and drawing high amps. C. There is an open circuit between the relay output and the contactor coil. D. The chiller is low on refrigerant, causing compressor lockout. Answer. Correct answer. C. Explanation. An energized relay with no output current suggests a break in the wiring or a faulty connection to the contactor coil. BIKE 11 and NEC 310 support checking continuity and circuit integrity first. The mechanical compressor failure, B, or refrigerant lockout, D, would not explain lack of current to the coil. Coil overcurrent, A, would likely trip protection devices and not manifest as current. Question 5. A demonstrated biopreventative maintenance log review. A 3-year-old HVAC system aboard a research vessel is experiencing gradual temperature drift in multiple zones. Filters are clean, refrigerant pressures are stable, and no alarms are active. What should technician know prioritize for further inspection? A. Replace all thermostats with programmable units. B. Check the calibration of sensors and inspect duct insulation for degradation. C. Bypass control logic and run the compressor continuously. D. Reduce fan speeds to allow longer cooling cycles. Answer. Correct answer. B. Explanation. Sensor calibration drift and degraded insulation lead to poor thermal control despite correct refrigerant levels. According to ASHRAE and EPA best practices, proper sensor calibration and duct insulation integrity are key for maintaining performance. Bypassing logic, C, is dangerous. Replacing thermostats, A, doesn't address the root cause. Slowing fans, D, can reduce air circulation and worsen uneven temperatures. Question 6. In contrast to traditional HVAC systems, marine HVAC systems often utilize centrifugal pumps for chilled water distribution. Which of the following best explains why? A variable frequency drive, VFD, is advantageous in this application. A. VFDs decrease the refrigerant charge required in the system. B. VFDs increase the resistance in the piping network. C. VFDs allow modulation of pump speed to match cooling load and save energy. D. VFDs are only used to start pumps at high torque levels. Answer. Correct answer. C. Explanation. VFDs are critical for energy-efficient chilled water systems, allowing pump speed modulation based on system demand. According to ASHRAE, VFDs significantly reduce power usage in part load conditions. Option A is unrelated to water pumps. Option B is incorrect. VFDs reduce pressure losses, not increase them. Option D is too narrow use case. Question 7. While examining the ventilation layout of a luxury catamaran, technician Dana notices poor air delivery to aft cabins while forward areas are overcooled. Duct inspection reveals no damage. What is the most effective corrective action? A. Increase overall system airflow by upgrading the supply fan. B. Install balancing dampers and adjust airflow rates to individual zones. C. Replace the ductwork with rigid aluminum pipes. D. Close vents in forward areas to force air rearward. Answer. Correct answer. B. Explanation. Imbalanced air distribution is typically corrected with zone-specific dampers, allowing technicians to fine-tune airflows. This aligns with the CAM Manual D and ABIC guidelines for duct balancing. Increasing overall airflow affects noise and energy usage without solving distribution. Closing vents D may cause back pressure. Replacing ductwork C is unnecessary if structurally sound. Question 8. The fundamental question is what happens in a marine direct expansion system if the expansion valve is stuck in a fully open position. A. Suction pressure will drop and frost will form on the evaporator inlet. B. The compressor will cycle more frequently due to low load. C. Flooding of the evaporator will occur, risking compressor damage due to liquid return. D. Head pressure will spike immediately, tripping the high pressure switch. Answer. Correct answer. C. Explanation. An open expansion valve allows excess refrigerant into the evaporator, risking compressor slugging, liquid return. This is a serious failure scenario. Suction pressure will actually rise, not drop late, and head pressure D won't spike initially. Frequent cycling B typically results from low evaporator load, not overfeeding. EPA and manufacturer service manuals warn against TSSB failures. Question 9. Given the circumstances aboard a fisheries vessel, technician Pablo must troubleshoot a cold storage locker maintaining -18 deck for seafood preservation. The system seems to cycle excessively, and the stored products are showing partial thawing at the bottom. Which of the following is the most likely contributing factor? A. Evaporator fan is oversized for the volume. B. The defrost cycle timer is set too frequently. C. Condenser is oversized and causes low pressure. D. The thermal expansion valve is set to superheat too high. Answer. Correct answer. B. Explanation. Excessive defrost cycling can cause product thawing due to heat input and inadequate run times. ABIC refrigeration standards recommend carefully timed defrost to prevent temperature instability. Oversized evaporators A and condensers C would not typically cause thawing. A high superheat D limits evaporator efficiency but is less likely to cause thawing and less extreme. Question 10. When evaluating the merits of refrigerant management programs aboard ships, which of the following best demonstrates compliance with both U.S. EPA and international MARPOL and Cromany regulations? A. Maintaining a log of refrigerant purchases only. B. Using reclaimed refrigerant exclusively during maintenance. C. Recording all refrigerant recovery charging and leaks in an onboard service log. D. Delegating refrigerant tracking to an unlicensed crew member. Answer. Correct answer. C. Explanation. Both EPA 608 and MARPOL Romani require detailed refrigerant tracking, including recovery, servicing, and leak repair documentation. Maintaining purchase logs A is insufficient. Reclaimed refrigerant use B is encouraged but not a substitute for logging. Unlicensed personnel D are not permitted to handle refrigerants or documentation under EPA rules. Question 11. In light of recent developments in heat exchanger design, engineer Carla is tasked with evaluating whether to replace the plate heat exchanger in a vessel's chilled water system. The vessel operates in tropical waters where seawater intake temperatures remain above 30°. What thermodynamic principle is most critical in assessing the performance of the existing exchanger? A. Radiation heat loss from condenser housing to ambient. B. The specific enthalpy difference between refrigerant phases. C. The logarithmic mean temperature difference LTD between seawater and chilled fluid. D. The effect of mechanical fastener torque on heat transfer. Answer. Correct answer. C. Explanation LMED is essential for analyzing heat exchanger performance, especially when inlet and outlet temperatures vary as in seawater-cooled systems. It quantifies the effective driving force for heat transfer. Enthalpy B applies to refrigerant phase change but not cross-fluid heat exchange. Radiation A is negligible in fluid systems. Fasteners D relate to mechanical stability, not heat transfer. ASHRAE and ABEC P1 guidelines support LTD-based selection. Question 12. Through the lens of modern troubleshooting practices, technician Marcos is diagnosing a suspected refrigerant undercharge in a ES system aboard a scientific research ship. The system serves multiple zones and uses electronic expansion valves (EVs), which tool combination provides the most accurate diagnostic approach. A. Manifold gauges and a clamp meter. B. Temperature probe and a megameter. C. Clamp meter and combustion analyzer. D. Digital pressure enthalpy chart software and thermistor temperature readings. Answer. Correct answer. D. Explanation. ERF systems require dynamic, zone-sensitive diagnostics. Using a digital pressure enthalpy tool with thermistor-based temperature measurements allows precise superheat subcooling analysis. This method aligns with EPA and manufacturer recommendations. Manifold gauges are less effective of ERF systems. A megameter B is for insulation testing. Combustion analyzers C are unrelated to refrigerant diagnostics. Question 13. The underlying principle of energy conservation aboard marine vessels is being evaluated by technician May, who is assessing a hybrid chiller plant serving both passenger cabins and engine room cooling loads. Which system adjustment offers the highest potential for increasing energy efficiency under variable load conditions? A. Replacing chilled water pumps with fixed speed models. B. Maintaining constant compressor operation regardless of demand. C. Implementing load-based staging of compressors and VFD pump control. D. Closing dampers in unused zones to increase system pressure. Answer. Correct answer. C. Explanation. Compressor staging and VFD control allows systems to match output to demand, greatly improving energy efficiency under part load. This is supported by ASDO and ASHRAE 90.1 marine applications. Fixed speed pumps say waste energy. Constant operation B is inefficient. Closing dampers D may cause static pressure buildup and equipment damage. Question 14. In the context of confined space entry aboard marine vessels, technician Ravi is dispatched to service an air handling unit inside a poorly ventilated bilge compartment. What should be his first action before proceeding with any work? A. Wear a face shield and begin inspection immediately. B. Ventilate the compartment and test for oxygen deficiency and flammable gases. C. Ask a second technician to stand by the compartment entrance. D. Proceed as long as there are no visible hazards. Answer. Correct answer. B. Explanation. Confined space entry requires atmospheric testing for oxygen, flammable gases, and toxic vapors per OSHA 29 CFR 1915 subpart B and a bike H2. Ventilation and gas detection are mandatory before entry. Standby C is important but not sufficient without testing. Visual inspection alone. D cannot verify safety. A face shield A is inadequate protection in atmosphere hazard zones. Question 15. When considering HVAC systems on hospital ships, technician Annika is reviewing air purification strategies for isolation rooms. What method provides the highest level of airborne pathogen control as required in marine medical environments? A. Use of MERVATE filters and sealing diffusers. B. Installation of HEPA filters with dedicated exhaust and negative pressure. C. Installation of UV lamps alone at return ducts. D. Recirculation of cabin air through standard washable filters. Answer. Correct answer. B. Explanation. HEPA filters combined with negative pressure and dedicated exhaust ensure airborne contaminants do not spread. This meets ASHRAE 170 and CDC guidelines for healthcare spaces. MERVATE A does not capture submicron pathogens. UV lamps alone. C. A supplemental, not primary methods. Recirculation. D. Risks cross-contamination. Question 16. By evaluating the seawater cooling loop of a luxury yacht, engineer Victor finds pump cavitation is occurring during high-speed operation. Which factor is most likely responsible? A. The pump inlet is submerged too deeply below the waterline. B. Air is leaking into the discharge side of the pump. C. Net positive suction head NPSH available is lower than NPSH required. D. The system is operating with chilled water instead of seawater. Answer. Correct answer. C. Explanation. Cavitation occurs where NPSH available is insufficient, causing vapor bubbles that damage pump internals. Beacon pump manufacturer guidelines require an HVACR. Deep submersion is not an issue unless it affects priming. Discharge side air leaks B are rare. Fluid type D is unrelated to cavitation unless it changes vapor pressure drastically. Question 17. According to recent studies on marine food preservation, what is the most efficient defrost strategy for a marine walk-in freezer operating in high humidity tropical climates? A. Defrost only when ice visibly accumulates. B. Schedule defrost cycles based on estimated door usage times. C. Implement adaptive demand defrost based on coil temperature sensors. D. Use continuous low temperature defrost to prevent cycling. Answer. Correct answer. C. Explanation. Adaptive defrost systems use sensors to monitor core conditions, initiating defrost only when necessary. This saves energy and maintains consistent temperatures as per DOE Energy Start practices. Visual A or time-based. B. Approaches are inefficient. Continuous defrost. D. Wastes energy and risks product damage. Question 18. In a modern context of marine electrical systems, technician Jerome encounters a capacitor start induction motor that fails to start but hums when energized. What is the most probable cause? A. The run capacitor is shorted. B. The start capacitor or start winding has failed. C. The load on the motor is too light. D. The line voltage is slightly above nominal rating. Answer. Correct answer. B. Explanation. A humming, non-starting motor suggests the start winding or capacitor has failed. NEC Article 430 and a bike E11 indicate that start components must be tested during motor failures. Run capacitors affect running performance, not startup. Overvoltage D would not typically cause this symptom, and a light load C would not prevent starting. Question 19. Considering the evidence gathered from maintenance logs, a cargo vessel's galley exhaust fan routinely fails due to grease buildup. What design change would best reduce maintenance and fire hazard risk? A. Replace the fan with a more powerful unit. B. Relocate the exhaust outlet closer to the cooking station. C. Install grease-rated ductwork and unlisted hood filters. D. Reduce exhaust frequency to low firmware. Answer. Correct answer. C. Explanation. Grease-rated ducts and unlisted filters are required by NFP 896 and by H2 for galley systems to manage flammable residues and prevent duct fires. Simply increasing fan size A. Does not address fire risks. Shortening duct runs B. Can worsen heat exposure. Lowering fan use D. Increases grease accumulation. Question 20. To what degree does proper documentation influence marine HVAC maintenance effectiveness? Technician Lele is implementing a digital log system for multi-deck refrigeration on a container ship. Which practice is most essential? A. Recording only compressor amperage during inspections. B. Keeping handwritten logs on the unit itself. C. Documenting refrigerant quantities, pressure readings, and service actions with timestamps. D. Logging failures only when components are replaced. Answer. Correct answer. C. Explanation. Comprehensive logs with refrigerant levels, pressures, diagnostics, and timestamps enable proactive maintenance and regulatory compliance with EPA Section 608 and MARPOL. Compressor amps alone are insufficient. Handwritten notes B can be lost or incomplete logging only replacements. D omits preventative insights. Question 21. By comparing performance data from a multi-deck yacht, technician Oscar notices that indoor ERF emits intermittently report the communication error across zones even though cooling demand is met. What is the most likely root cause? A. Expansion valves are stuck in the closed position. B. The outdoor unit is undercharged with refrigerant. C. Signal interference or grounding issues within the communication wiring. D. Fan speeds on indoor units are improperly set. Answer. Correct answer. C. Explanation. In ERF systems, the errors typically point to communication faults between indoor and outdoor units. Grounding, shielding, or cable interference are common culprits, especially on vessels where electrical noise is high, while refrigerant issues, B, and fan speeds, D, can affect performance. They do not generate communication-specific faults. ABIKE 11 outlines marine wiring standards that address it. Litigation. Question 22. A detailed analysis of refrigerant loss on a fishing vessel reveals repeated leaks at brazed joints in the suction line. Technician Harriet suspects the problem lies in the brazing technique. Which of the following best improves joint reliability in this scenario? A. Use a lower silver content filler metal for improved flexibility. B. Perform brazing using air instead of nitrogen to accelerate cooling. C. Purge with nitrogen during brazing to prevent internal oxidation. D. Switch from brazing to soldering to reduce heat exposure. Answer. Correct answer. C. Explanation. Purging with nitrogen during brazing prevents oxidation and scale formation inside copper lines, which can cause future leaks or compressor damage. This practice aligns with industry best practices and manufacturer guidelines. Using air, B, causes oxidation. Soldering, D, lacks strength for suction lines. Low silver content, A, may not provide the strength needed in marine vibrations. Question 23. From a practical standpoint, why is R134 or more commonly selected than R400 TINA for chilled water systems aboard cargo ships? A. R400 TINA has better oil return characteristics and long piping runs. B. R134 operates at significantly lower pressures, enhancing safety and component life. C. R134 requires larger compressors, which is beneficial in marine applications. D. R400 TINA is more compatible with seawater heat exchangers. Answer. Correct answer. B. Explanation. R134 is preferred in marine applications for its low pressure operation, which reduces component stress and safety risks in high vibration environments. R400 TINA, although efficient, operates at much higher pressures. Option is misleading. Oil return depends more on velocity than refrigerant type. Larger compressors, C, are not inherently beneficial. Compatibility with heat exchangers D. Depends on materials, not refrigerants. Question 24. While examining a self-contained AC system on a pleasure craft, technician Kelvin finds that the unit cycles off prematurely before reaching set point. The digital controller displays no errors. What is the most probable issue? A. High pressure cutout due to clogged seawater strainer. B. Oversized system causing short cycling. C. Blown start capacitor on the blower motor. D. Low voltage at the compressor terminal. Answer. Correct answer. B. Explanation. An oversized HVAC system cools the space too quickly, leading to short cycling, humidity issues, and increased wear. The bike standards recommend proper load calculations to avoid this. High pressure cutout A would cause a fault code. A blown capacitor C would prevent blower operation entirely. Low voltage D may cause failure to start but not short cycles. Question 25. The prevailing attitude toward dehumidification aboard luxury vessels emphasizes comfort and mold prevention. If an HVAC technician observes that relative humidity remains above 70% even when air temperature is lowered, what control adjustment is most appropriate? A. Increase the chilled water temperature set point. B. Decrease the supply air temperature and airflow rate. C. Increase outside air ventilation to improve dilution. D. Raise the thermostat set point to reduce compressor runtime. Answer. Correct answer. B. Explanation. Lowering supply air temperature and reducing airflow increases latent heat removal, enhancing dehumidification. HVAC psychrometric principles confirm that slower airflow allows better moisture extraction across the coil, raising the chilled water temp A or thermostat. D reduces cooling and moisture removal. More outside air. C can introduce additional humidity. Question 26. Correct answer. B. Explanation. Lowering supply air temperature and reducing airflow increases latent heat removal, enhancing dehumidification. HVAC psychrometric principles confirm that slower airflow allows better moisture extraction across the coil, raising the chilled water temp A or thermostat. D reduces cooling and moisture removal. More outside air. C can introduce additional humidity. Answer. Given the circumstances aboard a container ship, technician Dana is asked to optimize cooling for a reefer unit holding perishable goods. The compressor runs continuously, but the set point is not achieved. Inspection shows evaporator coils are clean and airflow is unobstructed. What is the next most likely problem? A. Dirty condenser coils reducing heat rejection. B. Short cycling of defrost timer. C. Incorrect refrigerant charge resulting in low suction pressure. D. Faulty temperature sensor reading inaccurately. Question 27. Given the circumstances aboard a container ship, technician Dana is asked to optimize cooling for a reefer unit holding perishable goods. The compressor runs continuously, but the set point is not achieved. Inspection shows evaporator coils are clean and airflow is unobstructed. What is the next most likely problem? A. Dirty condenser coils reducing heat rejection. B. Short cycling of defrost timer. C. Incorrect refrigerant charge resulting in low suction pressure. D. Faulty temperature sensor reading inaccurately. Answer. Correct answer. A. Explanation. Dirty condenser coils prevent efficient heat rejection, causing the system to run longer without achieving set point. This is especially critical in high ambient marine environments, while low charge C or sensor faults D could contribute. Continuous compressor operation typically points to insufficient heat rejection. BIC recommends regular condenser cleaning for refrigeration systems. Question 20. From multiple perspectives, managing ventilation in galley spaces aboard vessels presents fire and hygiene challenges. Which of the following best supports compliance with the BIC H2 and NFPA 96 standards for galley exhaust systems? A. Install flexible ducting for easy routing around bulkheads. B. Use a dedicated exhaust hood with grease-rated ductwork to the exterior. C. Recirculate exhaust through charcoal filters to reduce odors. D. Tie galley exhaust into the general HVAC return duct system. Answer. Correct answer. B. Explanation. Dedicated grease-rated hoods and ducts are required by NFPA 96 and above to handle grease vapors, prevent fire risk, and ensure safe discharge. Flexible ducts, say, are not fire-rated. Recirculation. C. Is not permitted for grease-laden air. Return duct integration. D. Risks contamination and fire spread. Question 29. In what ways can selecting the wrong compressor type for a marine HVAC system create long-term reliability issues? A. Hermetic compressors improve serviceability and should always be used. B. Marine systems should only use scroll compressors due to noise. C. Selecting a compressor with low displacement for a high head application causes overheating and failure. D. Reciprocating compressors have no application in marine systems. Answer. Correct answer. C. Explanation. Undersized compressors in high head pressure conditions overheat, leading to failure. Marine HVAC designs must consider pressure-temperature relationships and load conditions. Hermetic units. A. Reduce serviceability, not improve it. Scrolls. B. Are common but not universal. Reciprocating compressors. D. Remain viable, depending on system specs and redundancy needs. Question 30. Throughout the course of a scheduled inspection, engineer Helena discovers that the seawater pump shows high current draw and vibration. The strainer is clean and flow rate is reduced. What should she inspect next? A. The expansion valve setting. B. Shaft misalignment or impeller damage inside the pump. C. Chilled water loop pressure. D. Circuit board faults in the control panel. Answer. Correct answer. B. Explanation. Vibration and high amp draw-in. A pump with low flow and a clean strainer suggest mechanical issues like shaft misalignment or impeller wear. A BIC P1 recommends periodic mechanical alignment checks. Expansion valves. Say, and chilled water pressure. C. Do not impact pump load directly. Control boards. D. Would not cause vibration.